Good morning all. Today we will solve a numerical question on logarithmic transformation. An 8-bit digital input image it is given to us, and on this given digital input image we have to perform the logarithmic transformation. For the same, first we have to determine the value of the constant c, and then after we have to perform the logarithmic transformation. So let us solve this question. So we have a 8-bit digital input image. So n equals to 8. So for n equals to 8, the number of gray label L equals to 2 to the power 8, that is equals to 256. Their representation, it starts with the minimum gray label, that is 0, to the maximum gray label, that is 255. So for an 8-bit digital input image, my input intensity level R, it is varying from 0 to 255. So for an 8-bit digital input image, the input intensity level R, it varies from 0 to 255, and we want our output intensity level S will also vary from 0 to 255. We know the general equation of logarithmic transformation. It is S equals to C log 1 plus R. Where R represent my input intensity level, S represent my output intensity level, and C represent the constant. So in order to perform the logarithmic transformation for an 8-bit digital input image, we have to determine the value of C. For the same, we will apply the boundary condition when R equals to 255. When my input intensity level R equals to 255, our output intensity level is also equals to 255. So in order to determine the value of C in this equation, in place of S, I will substitute 255. In place of R, I will substitute 255. So my equation become, in place of S, I will substitute 255. So it becomes 255 equals to C log 1 plus R. In place of R, I will substitute 255. So it is 1 plus 255. If you rewrite this equation, then the equation of C, it becomes C equals to 255 divided by log 256. If you simplify this expression, we will get 105.886. So if you round up this number up to 2 decimal place, it becomes equals to 105.89. So we have determined the value of C. For an 8-bit digital input image, it is 105.89. Now the value of C, we will substitute in this equation, and we will determine the equation of S. So in this equation of S, if we substitute the value of C, which is equals to 105.89, then the equation of S becomes S equals to 105.89 log 1 plus R. Now we will use this equation in order to perform the logarithmic transformation on the given digital input image. So this is the given digital input image. On this given digital input image, we will apply the logarithmic transformation. The equation of S that we obtained, it was S equals to 105.89 log 1 plus R. So we will apply this logarithmic transformation equation on the given digital input image, and we will determine our output image. Since the dimension of the given digital input image, it is 2 cross 3, 2 number of rows and 3 number of column. So my output image dimension is also 2 cross 3, that is 2 number of rows and 3 number of columns. Now one by one we will apply the logarithmic transformation. First, for this pixel whose intensity level it is equals to 10. So when r equals to 10, we will compute the response. In this equation of s, in place of r we will substitute 10. So the equation of s, it becomes equals to 105.89 log 1 plus, in place of r I will substitute 10. So it is log 1 plus 10. If you simplify this, it is log 11. And if you simplify this up to 2 decimal place, it is 110.27. Next, we will round off this number to its nearest integer number. 110.27, the nearest integer number, it is 110. So for my input intensity level r equals to 10, we have determined the response that is equals to 110. So here I will write 110. Next, for my input intensity level 30, when r equals to 30, in this equation of s, in place of r I will substitute 30 and we will compute the response. So s equals to 105.89 log 1 plus 30. So if you simplify this up to 2 decimal place, it is evaluated to be 157.92. Next, we will round off this number to its nearest integer number. 157.92, the nearest integer number, it is 158. So for my input intensity level 30, I have determined the response, it is 158. So here I will write 158. Next, for the input intensity level 50, when r equals to 50, in order to compute the response, in this equation, in place of r, we will substitute 50. So the equation of s becomes 105.89 log 1 plus 50. If you simplify this up to 2 decimal place, it is 180.81. Next, we will round off this floating point number to its nearest integer number. 180.81, its nearest integer number is 181. So for my input intensity level 50, we have determined the output intensity level, that is 181. So here I will write 181. Next, for the input intensity level 70, when r equals to 70, in order to compute the response, in this equation, in place of r, we will substitute 70. So the equation becomes 105.89 log 1 plus 70. If you simplify this, it is evaluated to be 196.029. If you round off this number to its up to 2 decimal place, it is evaluated to be 196.03. 196.03. Next, we will round off this floating point number to its nearest integer number. 196.03. The nearest integer number is 196. So for my input intensity level 70, we have determined the response, it is 196. So here I will write 196. Similarly, for my next intensity level 200, when r equals to 200, we will determine the response, and for the same, in this equation, in place of r, we will substitute 200. So the equation of s becomes 105.89 log 1 plus 200. If you simplify this, we will get 243.885, and up to 2 decimal place, it is evaluated to be 243.89. Next, we will round off this floating point number to its nearest integer number. 243.89, the nearest integer number, it is 244. So for my input intensity level R equals to 200, we have determined the response, it is 244. So here I will write 244. Next, for the intensity level 240, when R equals to 240, in order to compute the response, in this equation, in place of R, we will substitute 240. The equation of S becomes 105.89 log 1 plus 240. If you simplify this, you will get the response 252.23. Next, we will round off this floating point number to its nearest integer number. 252.23, nearest integer number, it is 252. So for my input intensity level 240, we have determined the response, that is 252. So for this given question, we have determined the value of C, and after that we have performed the logarithmic transformation on the given digital input image, and we have computed our output image. And with this question is over. Thank you all.